Welcome back to the Electronics Inside. I'm David and today we're doing slot cars. There's going to be a lot to go through, so let's rush into it. So this first set, which has obviously seen better days, is at the risk of offending anyone, I think is really old. This one comes from 1974 and you can tell by the box it's been used. So the hobby and practice of slot car racing apparently dates from 1912, as early as that, and it's very closely related to sort of model railways as a hobby, and some of the scales tie up and there's obvious lineage which follows it. Scalextric, as a UK-based company, came around in 1957, and this set in particular comes from 1974, which means it'll be 50 years old next year in 2024. And I really love the fact that this has still got, yes, very ripped, but instructions. It's still got a little magazine that came in the box, which puts a nice date on it, 1974. And this is the 15th edition. So the original one of these, assuming there was one per year, would have been 1960. I don't know if this was an annual release. Seems sensible. But the illustrations are just beautiful in this. I mean, it's just 1974. The typefaces, the photos, it's awesome. I think this is the track, this layout, the Formula 1 GP8 set. I remember having that banked corner, having to clip on the barriers, having that little tight weavy bit, and this style of controller and transformer, which is why I wanted to get this set, because I showed this to my son, who is currently 7 years old, and he thought trying to set this up made you look like an electrician. And when you compare it to the new models, I can see why. So in this box we have the relatively familiar track. I would weirdly say this is like slightly more rubbery than the modern stuff, whereas the modern stuff's more plasticky. I hope that makes sense. Like, this has got more flex to it. But yeah, this track has obviously seen a lot of wear. It's taken off that sort of chromed or corrosion resistant finish and has now just started going rusty, which is really sad, but it's one of those things that happen. I wonder if you can get replacement metals or whether there is a process to electroplate these back up to high quality finish. I mean, yeah, sure, I could run wire wool over it, but that would just expose more steel, which would rust again. Obviously, even the rubbers of the tyres have seen better days. Let's get to the business end. Okay, so here are the cars. Like I say, some of the rubbers and the plastics haven't aged particularly well. I really understand why there's a red and a blue tail in there, but there you go. If you look at the underside of these cars, you can see this crown gear, the pinion gear, and the exposed motor with the stator and the rotor. And there are instructions on how to lubricate this. You've obviously got the brushes that pick up from the track, and the wiring is all very much exposed. There is a little ceramic or tantalum cap in there just to help with the inrush current. And the last thing of any notice on here is the brushes. On the back of this motor, it's actually a brushed motor, making it a universal motor. So this will run on AC or DC, but the brushes are sprung and will wear out. So anyway, that's the cars that came. What I really wanted to show was the transformer and controllers, because I mean, I think my memory of this big blue cylinder transformer hasn't changed at all, but I remember this being actually slightly easier to understand back then than it is now. Each controller with their different coloured wires. The blue controller has a grey wire, yellow controller has a black wire. They come down to these little connectors which plug onto the underside of the track, and that's how the track gets its power. And then you have two ring lugs, one that come from the track and one that goes on the other side to the controller. So as a circuit diagram, imagine transformer up to controller, which we'll come back to, from the controller back into the track. So from the track, you then go through the motor back to the transformer. It's a really simple circuit. Now, the fact that you had to sort of unscrew these terminals, put a pair of ring lugs on, You had to make sure you got the same leg of the wire, otherwise one car ran a different direction to the other. Ideally you want the ring lugs so the flat sides are together, because ring lugs, they're sort of flat on the back side where the bit that crimps onto the wire has been folded up. So you want the two flat sides together for best contact, slip them over the terminal and then screw them back down. And of course, inevitably, as children, when we were playing with these, the wires would get tugged and pulled around like this, and eventually that screw would work itself loose. And one of the cars would stop working, you'd get little bits of arcing from the transformer. It was scary, but we knew you just had to kind of tighten it up. The idea that you're sort of making those terminations and there are things that are loose which could become live, and there were sparks in this for a children's toy in the 21st century when I have my own kids feels noticeably different to the attitude that we have today. But I think I would love to let my kids play with this and see how long it would take them to work out and fault find all of these issues and learn how to deal with them. Anyway, that is the old style, and this is what I was familiar with of slot car racing when I was young. Let's jump forward to what it looks like now. I'm not sure either when this is from. Either way, this is significantly more modern than the 1974 kit. And the track... Wow, that felt eventful. The track, like I said, is less flexible. It feels more like plastic than rubber, although thinking about it, that could be age. They've also now adopted a slightly different style of how it connects. It's now got this sort of slot and tab type thing, whereas the old style was those two round rings. Otherwise, this all works pretty much functionally the same. We've still got controllers, we've still got a switch mode power supply this time, which just plugs into the mains and plugs into a specific part of the track. Which is this bit. And switch mode power supply at 12 volts into the track. Yes, I trust my children to do that. This is now DC rather than the unrectified AC that came in the 1974 version. It's much more straightforward. Especially now that we use 3.5mm jacks in the receiver. It's pretty hard to get wrong. Now, I have seen people, animals touch this, and you're not going to get a bad shock from a limited current source at 12 volts, but you can feel it, especially if you've got damp or wet hands. If you had your fingers across both sides of that track and somebody was giving it full beans, you would feel it. Anyway, there's not too much to this one. The first thing I really want to get inside is comparing one of the modern controllers to the 1970s controllers, because I think that's going to be our first difference, but potentially not much. So the style has changed somewhat, but they essentially do the same thing. I'm pretty sure if I got a multimeter and plugged it in here, we'd find both of these are just variable resistors or rheostats of some kind. So I'm going to start with the new one just because I can see the screws on it. So yeah, just a spring, a trigger, and a nice rheostat, which for all intents and purposes is a wire-wound variable resistor. And I can tell you that's exactly what's in here because you can kind of see it through the top. There is differences in construction though. There you go, you can see the construction in here is far more rudimentary, but basically still the same components. So the wiper is a separate part and sits on this metal shaft, and that was connected to that metal shaft using a little ring lug again, and the other side is onto this fiberglass, or is that Paxoline? But again, it's a wire-wound rheostat. It's a really simple construction, and that didn't change. I believe still hasn't changed. I think this is still essentially what you get if you go for a non-digital Scalextrics. So if it ain't broke, don't fix it. I will note, of the three sets, these are my favourite cars. They've got the most detail on them and they look awesome for it. They just look way cooler than the other cars that came even in a kit that's basically the same age. And I guess that's where they put the extra budget, because the other kit I've got has probably got more of a bill of materials in it. But as it happens, this car has seen some crashes, so I don't feel too bad taking this apart, because it could do with a bit of love anyway. So they've still maintained the same brush style from 1970 to the early 2000s. User serviceable part and different gear configuration. We will see why when we get inside. Also, before I do take the cover off, please notice that this has got an extra compartment with, in this case, nothing behind it apart from a couple of connections. Now I know what you're all thinking, why would you have the connections there? Why pay for the bill of materials if you don't need it? Keep that in mind. Also note this car now has a little magnet here which helps keep it on the track. Just there. So now we have a motor without serviceable brushes, still got a capacitor but it's inside a little bit of heat shrink, and the gears are now not a crown gear, they're axial, which is a detail I absolutely love for one reason. Let me get the instructions. So these are the instructions that came with this kit. So you can see on here you've got the switch mode power supply, the modern controllers, the 3.5mm jacks, that new plug. So this is definitely the right set of instructions for it. But if you look down here at the instructions on how to clean the motors and how to lubricate them, they still have details and instructions with that crown gear and pinion at 45 degrees in the old position of the motor. Now, is that just like a throwback to when they still did that? Or is there different types of cars that still have the perpendicular motor? Answers in the comments on the Element 14 community, please, because I've already bought, shamefully, this isn't even the full set. I have another one in the loft, which I'd completely forgotten about. I have 4 sets of Scalextrics in this house right now. Maybe I have a problem. Can you see what's new? Come 2004, Scalextrics went digital. Yeah. This track is physically compatible with the other recent analog track, and here's the digital track, and they are cross-compatible. Now your first clue that something is up here, or at least other than the word digital on the box, should be these 2 bits of track side by side. This piece came from the analog set, and this piece came from the digital set. Notice how different they are. On this one, the 2 tracks cross over and are insulated from each other by this little bit of plastic in the middle. If I show you the underside, you've got this little panel here that connects these 2 bars and these 2 bus bars. That means that these 2 can be different potentials than these 2. They're the 2 tracks you can use. At some point elsewhere in the track, you have to uncross those lines, otherwise they both become the same track and the cars will always go the same speed. Compare that to this piece of work. You've got something going on down here with some circles. We'll look into it. And then you've got these, I'm going to call them points, because they look like railway points. And like I said, a lot of slot car racing comes from model railway building. So yeah, these points, which means dynamically this car can choose to carry straight on, or it can choose to change track. And that leads to some very interesting behaviour where, traditionally on Scalextrics, if you put both cars on one track and pull a trigger, they both move together at the same speed and it's very boring. This, however, you can have both cars on one track or changing tracks to join each other, and you can have up to 4 cars going around a 2-slot track trying to overtake, undertake, change lanes. How do they do that? It's very obvious from the outset that we have moved away from a very simple circuit and a basic circuit diagram. There is something clever going on inside digital Scalextrics. Let's go into it. So, controller, switch mode, power supply, car, and special track. All of these things are now very, very different and not cross-compatible with any of the old kit directly. Well, let's just have a quick look at the switch mode power supply. Like I say, it's going to be significantly bigger because it can carry more cars. So this is now 15 volts at 4 amps. So that's 60 watts. That's, I mean, it's a chunk. It's obviously not going to draw that the whole time, but as a maximum capacity, that's not insignificant. We now have a barrel jack on the end, which plugs into the side of the start-finish straight. Obviously, you've got your 4 controller ports, which I have reduced down from 3.5mm jacks to 2.5mm jacks, were they? But they are still only 2-pole, or tip and sleeve. The controller, it's got buttons. So we've still got the reasonably traditional, or at least appearing to be traditional trigger. I think it probably makes that noise because it's got a spring in it. I'm not sure this is going to have a rheostat in it anymore. And it's got 2 buttons on the back. Now, one of these asks when the car drives past this point here. If you hold that down as it passes, it will switch the track from straight on to change tracks. The other button is a brake. So with Scalextrics, you typically let go and the car will coast to a stop pretty quickly. These motors cog quite badly. But with this, you can keep your finger down and also tap that brake. I can't really see the benefit of that because these things brake hard and fast to a stop. I feel like if you did that, you'd just crash your car into the next car on the same track. I don't know. So where shall we start? I say let's put the power supply to one side and go for a controller. Should we see what's inside a controller? We can straight away compare that to the other 2 we've already taken apart. Ah, look, printed circuit board and graphite film resistor, potentiometer. Definitely not the hard-wearing rheostat anymore. And that explains partly why these are so lacking sensitivity. With the rheostats, even on the 70s one, I can measure a really nice smooth voltage response. I can sort of press the trigger a little bit and see the voltage climb up. When I plug or attach a multimeter to this track, I can't measure anything. So I think it's going to be a case of plug this in and get a scope on it. But also, I don't measure any voltage, just weird. But also these cars have a habit of going from 0 to everything and nothing in between, which makes me think that the graphite film of the potentiometer is failing, failed, or dirty, or all of the above. So we've got 2 buttons on an IC and 2 resistors. Interesting. So these controllers are actually pretty dumb. And if you look, we just sort of go series in here through the potentiometer into this PCB with the 2 buttons and then out again. Now remember I said this has only got a 2-pole connector on it. So all you're going to be doing, or ideally doing, it clearly doesn't work properly if the potentiometer doesn't work, but let's say this is a, 0 to 10k potentiometer. So 0 to 10,000 ohms from full range of motion. Then on top of that you have, oh wow, it's even listed. So on this side it says 8.2k and this side it says 18k. So actually I'm going to revise what I said about the potentiometer and I will assume that it's 0 to 4k, something in that kind of ballpark. So all you do is attach a resistance meter across here or measure the resistance across here, or indeed the voltage drop if you just apply a voltage to it. And you can calculate how much resistance is in that circuit. And you notice that I said 4, 8 and 18 because those are all sort of exponents of each other. So you can always measure independently whether that 18k is applied or not. If you're measuring 36k, you know that it's 4 and 18. If you measure 19, you know it's 18k and 1k the potentiometer. You can work out by measuring the volt drop across here how many and what of these is applied at any one time. That's a nice little technique, and it means these are cheap. There is no intelligence in here other than the clever way this was laid out to begin with. I don't know how clearly you can see that, but I would say the graphite from that is basically worn right through. So this at the very least needs new potentiometers. I would like to get a multimeter on that later, check. So, controllers. Simple, but a nice solution. Shall we go for the cars next? This again is a nice example of where we can see some differences. We've still got the same brushes, same brush design, but we've now got this additional little LED here. And I tried, I couldn't actually work out if that was a normal visible light LED or an IR LED. The fact that I couldn't work it obviously out was probably symbolic of the fact it's an IR LED and I just couldn't see it with the naked eye. Let's jump into one of these cars and see what's different. Okay, so inside here we have lots of dust for a start, which could do with a clean right around the axle and everything. Lovely. Got that bar magnet. Oh, we've now got a ferrite choke and 2 capacitors on this motor. And again, we've used this parallel to the axle type configuration rather than perpendicular. what I can show you here is the reason for those cars having a little replacement panel. Do you recognise those 4 wires? If I compare that to this one, those 4 wires on the plug. So 2 come in from the track and 2 go to the motor. Everything else on that little board is self-contained, which means these cars have an upgrade path where you can get this circuit board and the LED on this little replaceable part, and you can upgrade these analog cars to digital cars. Okay, so we've established that the car has got some kind of circuit board for decoding a bus. That's about as much as I can say at this point. So let's jump onto this bit of switch track and have a look what's in here. I'm imagining it's going to be something incredibly similar, to be honest. Ooh, yeah, circuit board for LEDs. Ah, nice little solenoids for activation. Interesting, they've just sort of gone for a solenoid per direction. Like, I would have thought you'd just go with one solenoid and reverse the polarity, or even have it spring return. But I guess the advantage of not doing spring return is that the point would stay roughly wherever you position it. Then up here, yeah, just wire looping it all out. So actually this board is where all the intelligence is. You can see it picks up from one track, not even both. Fair amount going on this board. Well, I say more than I expected, but again, this is just bus addressable equipment. No. No, it's not bus addressable. All this has got to do is detect the 2 photodiodes of whichever car is coming over it and switch the tracks accordingly. So that connection to the track is just a power pickup. Yeah, that's all it needs, is power from the tracks. When this light is illuminated, change the points that are ahead of it. Right, I'm going to go out. I hate doing this because I'm never right. One of these is going to be a microcontroller and the other is going to be a packaged transistor set. We will find out how right or wrong that is later. So actually, that is clever, but not as clever as I thought it needed to be. So let's find out what this looks like. This has presumably got the most going on inside. So it's got to take those analog inputs from the controllers, convert it into the bus, and then feed it in here, as well as the power management from the mains incomer. One thing I haven't talked about so far in the history of slot car racing, like I said, it sort of started at the early 1900s, 1912 apparently, and is still going today as a hobby. But apparently in around the 1950s and 1960s, it became like a big deal, and there were sort of semi-professional and serious leagues going on. I'm sure they still exist, but at that period in time, they were common. Yeah, there you go. So in here, you can see both sides of the track are just kind of paralleled up. There's no separation between them at all, which is cool. Oh, there you go. Much better. Okay, tactile domes for the buttons, not even tactile switches, tactile domes, which is fine for this sort of application. Huge power diodes. It was DC input, wasn't it? Yeah, DC. So the huge diodes strike me as slightly unnecessary, but okay. Then we've got 4, they're not inverting this, are they? I mean, it even says sort of, I don't know if you'll be able to see this, sort of embossed on the back of this bit of track, 12 volts DC. But everything I'm seeing here, with the capacitors across the track and these 4 power transistors, MOSFETs, whatever they are, look like they're kind of inverting something. Then this I see over here, which is close to all the business end. PIC 16, it's a microcontroller. So does that mean that they are using the microcontrollers to essentially generate or replicate a custom bus? Be interesting to get the scope on this and actually see what sort of signal we get out of it. So again, those signals are 0, 5 volts, data, clock, and M clear. I can't obviously find what this works on, and that's really bugging me. So how should we do this? Shall we get the microscope out first so we can look at some of the ICs and be really clear what we're dealing with, and then we'll put it all back together and get the oscilloscope out and see if we can sniff any data being sent down this track. Seems like a sensible way to do it. Let's do that. I'm always a little bit disappointed when I get the microscope out, because looking through a binocular microscope at circuit boards and PCBs and components that are a millimeter thick looks amazing. Like, it looks like you're looking down at crevices and canyons and tower blocks from above, but I can only capture this in non-stereoscopic, so you only ever get the boring old 2D version, I'm afraid. Anyway, this is the PCB from the car, and there's clearly a lot of power electronics in here. So it looks like we have a clock here right next to what I can only assume is a microcontroller covered in dust and fluff. I'm really struggling to get data sheet for that. The HRN/ST doesn't seem to yield any kind of results for me, so I'm really struggling with that. I'm almost certain it's a microcontroller. I wonder if it's something that they've specially ordered, because HRN could be an abbreviation for Hornby, who now own Scalextric. And I wonder if they ordered enough of these in bulk between Scalextrics and their trains that they could have their own custom equipment spun up. So next to it we've got an amplifier, and over here we've got some half-wave rectifiers, which are weird because they're also being treated as diode, these FS1As. I'm pretty sure they're running the motors DC, but yes, I haven't got any feedback, so there'd be no advantage to turning it into AC and sending it to the motors. And if I flip this board over completely, on the other side, you can see in-car module, revision E. And this is where I can see 0 volts, 5 volts, data clock, and master clear as debugging headers. Now, that's what makes me think I have a good working theory to it, and I will come back to that in a minute when we look at the controller. And on the front we've got a couple of HL and SP headers. Ever on earth they are supposed to do. Almost looks like there's unpopulated resistors which could be externally added. Maybe there are cars with special features. Speaker maybe. Again, if you have good ideas, let me know in the Element 14 community. If you've got a car that has something on it that's not obvious that starts with the letters HL, headlights. Looking back at the points section of track, so there's a lot of repetitive circuitry here. We've got more of those half rectifiers essentially being used as diodes. Got the same crystal and controller again, HRN/SL, Hornby special something, I don't know, and I've tried looking for the other part number that's legible on here, 07124YB. Doesn't give me any hits at all. And then we trot to over here, we've got the same power regulator and amplifier. Don't think there's anything here we didn't really expect. Finally, let's have a look at this main board. Again, we can see those lovely tactile domes. Over here, this IC, this PIC16F819 controller. So that's what gives me an idea of how this will work, because that has 2 SPI buses. Now, SPI, if you're going to send and receive data from it, it needs more pins than we've got present at the controller level. You're supposed to have clock, data in, data out. We've only got a data and clock pins. But the cars don't need to send any information back to this controller. So I wonder if what we're looking at is integrating that SPI signal and clock onto the track with a load of signal handling and amplification, because obviously this has to transmit power as well, which the cars then receive, separate the power from the SPI signal, and then use that to control the car. What I don't know is how they've mixed the signal, the clock and the signal data together. That's my working theory. I think we are going to need to put the scope on here to try and work it out, and even then I'm not convinced I can work it out. Okay, so the first little mini test that I wanted to do was to show how the controller multiplexes, serializes all that data together to a single analog reading. So I've got a multimeter set up to measure the output pins, and like I said, with these all serialized together, if I press the 8K resistor, I get more or less 8K on there. The 18K resistor, I get more or less 18k on there. If I press them both together, of course, I get 26k. And I've only realised since that there's actually a 5k reading on here, which I was pretty pleased with 4k as a guess, but this is kind of the problem with the controllers, that graphite film across here. If I slide this up, should go nice and linearly from 0 to 5k. Yeah, it really doesn't. So yeah, that graphite potentiometer is just, yeah, that needs replacing. The components in it aren't expensive, even if they are custom. So it's really just how greedy a Hornby being, I think. Okay, so I've hooked up multimeter and the scope back up to the digital track, and I don't need the whole track because the left and right bus bar of each slot is in parallel, so that is a whole circuit. And what I've realised is if I put a multimeter in AC for this track, I get a reading, and I'm getting 15 or 14 and 0.3 volts, as you can see. If I put it on DC, I get essentially nothing, but in AC, I get a sensible reading. So they are actually inverting the DC back to AC, but not cleanly. So here you can see what, on the face of it, looks like a really ugly AC waveform. Of course, the cars, once they receive it, are rectifying it back to DC to use, so I don't really care how bad that sinusoidal waveform is. So if I now zoom in, I hold this. Now you can see this sort of square shape superimposed onto the AC waveform, and the voltage variation there is in 1 volt steps. So you've got this overall AC waveform of 15 volts RMS. Superimposed on that is sort of 1 volt noise, almost. If you look at this bit of data right in the middle, I'm pretty sure that it's using that 200 microsecond square wave as its clock signal, but it's also using the change during that 200 megahertz cycle as the data as well. So if you imagine that clean square wave becomes the clock signal. If you've got equal pulses, that's the clock signal. However, if you've got one that changes halfway through, that becomes significant data, so that becomes a 1. So clock and data, but it knows that that half wave is significant data, so it starts counting the clock again from where that changes. And I think that's non-return to zero, which is similar to how data is stored on CDs, as far as I can work out. And I think, from what we've seen on the PCBs, that data is actually SPI data. It's just being encoded onto an AC waveform. In case you hadn't noticed, this is new to me. I'll put it that, rather than saying it's out of my comfort zone. But I'm sure there are people that understand this or are familiar with the technology way better than I am. So jump into the comments over at the Element 14 community and share the right answers. Tell me where I'm wrong, or, you never know, tell me that I've guessed right. It happens occasionally. This is a much deeper dive than I expected it to for slot car racing, and this is kind of why I wanted to do this as a teardown, because I thought it might lead down some rabbit hole that led here. Try and keep it a little bit simpler than this one, because this has taken me hours. Let me know your thoughts and ideas. Thank you so much for watching. I'll see you next time.